from section 1.3. Part A asks us to find g of 0, and 0 is a q value, or a value of the independent variable. So we're going to first look at the horizontal axis and find a 0, and then go up until we intersect the graph and locate whatever this y value is, and it's 4, so g of 0 is equal to 4. In part B, we're asked to find the values of q for which g of q is equal to 0. Okay, so g of q, hey, that's another name for the function, or you could think about it as y equals 0. So I've drawn a line at y equals 0, and we want to find the q values where this line intersects the curve. And so we have a couple of places. One is at -2, and the other is at +2. So we'll write both of those answers down. In part C, we're asked to find the values of q for which g of q is equal to 3. Okay, so we'll do a similar thing as we did in part B. This time, draw the line at y equals 3 and find the intersection of the line with the curve. And it looks like there's 4 answers to this problem, and we're going to have to estimate what those values of q are. Okay, so we'll say maybe about -2.7, -0.7, +0.7, and +2.7. And lastly, we want to find the values of q for which g of q is less than 2. Okay, so we'll move our line down to y equals 2. We want to know the region of the graph where the y values are less than 2, so below this line. Okay, and there's 2 regions. One starting here at about -2.6, and then it ends around -1.1, and then another one starts at +1.1 and then ends at about 2.6. And in interval notation, we're going to use parentheses around each of these intervals because it doesn't ask when g of q is less than or equal to 2. We don't want to include the function values, the values of q when the function value is 2. So instead, just use parentheses and then join the intervals with a union.